Dear students, welcome to the third modules of our series of models about some mathematical study skills. In these models, the study skills that we consider, we will label it as Return to Basics. Please click on the Start button to proceed to the models. Many times to answer your questions, you need to go back to fundamental and basic concepts related to your questions, or to think about it, what is the basic objective of the questions? So you need to return to basics. Let us start with this example. The question says, without graphing, explain why the graph of f of x is equivalent to 10x squared minus x minus 40 plus e to the power x cannot have a point of inflections. To answer such a question, we need to go back to the basic information. So we need to know what is the point of inflections. Generally, it is the point on the graph of f where the graph changes concavity. Well, in practice, the information regarding concavity is obtained from the second derivative of the function. It is the point where the sign of f double prime is different before it and after it. It is known that if the point f of c is a point of inflections for the graph of a function f, then either the second derivative at c is equivalent to 0, or the second derivative of f at c does not exist. You could see from these computations that the second derivative is always positive for all real numbers x, and it is defined everywhere. So we conclude that f cannot have a point of inflections, and you answered the question. Now I think you are ready to test yourself. Try to go back to basics when you are solving the next question. Did you get the following answer? Please press on one of the buttons, yes or no. It seems that you need more practice, so let's solve the next problem. The question says, evaluate limit as x approaching infinity for x to the power n divided by e to the power x, when n is a positive integer. This limit has the indeterminate form infinity over infinity. So we could use L'Hopital rule here. So actually we need to use L'Hopital rule in times. Note that we could use the notations of factorial, and the value of the limit is going to be simply 0, since the denominator is going to be growing when x goes to infinity, and the numerator will be a constant n factorial. Now you are ready to answer the practice problem by returning back to basics whenever it's required. Wishing you best of luck. Good luck.